Hi everybody. Today we are going to learn the three laws of motions, Newton laws of motions. We'll talk about them, demonstrate them. First, the first rule. If the total force is zero, the object will remain in its state. Let's talk about this one. If an object doesn't feel any force, for example, I'm talking about the first law example. If this object doesn't feel any force, it means that it will remain in its state. What does it mean, remain in its state? It means that if it was resting, it will continue resting. If it had a certain velocity, it will remain with the same velocity. So, let's do a little example here. Suppose this object is resting on a surface. Which forces are applied on this object? We know mg, and we know the normal force. Now, if I know that this object, this body, this mass is at rest state, it means that the total force is zero. So, this force must cancel this one. So, N must cancel mg. Another example. Suppose I have a car and I know I accelerate on the gas pedal and it starts moving, and eventually it comes to a certain velocity and it remains in the same velocity. What does it mean? It means that it must be another force here, which we know it's the friction force. We didn't talk about it, but we know it exists. And this force and that force must be the same magnitude, opposite direction, because the total force must be zero and the car will remain in the same velocity. Same velocity and rest is exactly the same as far as Newton's first law is concerned. Another example, let's talk about spaceships. You know, when we are in space and we have a rocket there, a spaceship, it will remain in its state, it will remain in the same velocity. We don't need fuel in space in order to move, because once the rocket moves, it will remain in the same velocity. Why? Because there are no forces in space applied on it. So it will remain moving in the same speed. This is the first rule. Let's talk about the second rule. The second rule says that if the total force is not zero, for example, take this object, forget the surface now, and just push it or pull it with the force of F. We know that this object will start moving, start accelerating to the right, because there's no force here that can cancel this F force. So if the total force is not zero, this object will accelerate. How can we calculate the acceleration? We know that the total force, or the sum force, or the net force, or the resultant force on the body must be equal to, this is what Newton says, the mass of the body multiplied by its acceleration. This is the second law. We're going to deal with it a lot in the next lesson. So just the idea, if the total force is not zero, it means this body is accelerating, and to calculate this acceleration, we use this formula. The third law. The third law says that if I apply force, let's read it like that, when one body exerts a force on a second body, the second body will exert the same force in the opposite direction on the first body. Simple words, if I push the wall will push me back. If I push it at 100 newtons, it will push me at 100 newtons in the other direction. This is one example. Now let's see a few more examples that you must understand, because sometimes you mix this and that. Let's see. Let's talk about again a mass, which is on a surface. We know mg is down, normal force is up. I want to see the third law here on this object, on this mass. Let's see. These are not, although they are the same magnitude in opposite direction, they are not due to the third law. They are due to the first law, we showed it earlier. Why it's not the third law? If I want to see the third law here, let's see. This mass is pulled by mg force, gravitational force, due to what? Not due to the normal force, due to the gravity force, due to the Earth. Earth, if I were to draw Earth, planet Earth, and this is the mass staying here on the surface, the mass is pulled by mg due to the Earth force, the gravitational force. If I want to see the third law here, the third law says that if the Earth pulls this mass downwards, this mass pulls Earth upwards. This is the third law. So if I want to see the third law regarding the mg, I must draw the Earth. And I say, Earth is pulling the mass downwards, the mass is pulling Earth upwards. These forces are the same magnitude, opposite direction. We usually don't need, we don't have any business in applying this force, but if we want to understand the third law, this is how it applies. Let's talk then about the normal force. Normal force, this is the surface. Normal force, we said that the normal is due to the what? The surface applies on the object. This is the mass, and we say the normal force is because the surface applies force on the body. If I want to see the third law, it means I need to draw forces on the surface. The surface will feel exactly the same normal force, but downwards, the same magnitude, opposite direction. This is the third law here. This is how you see it here. The idea is, when you talk about the third law, only two bodies or two masses are involved. Normal force is due to the surface does on the mass, so the third law will, what the mass is doing to the surface. Mg force is what Earth is doing to the mass, so the third law will be what the mass is doing to Earth. Another example. Let's talk about a boy pulling a rope. Let's say the rope is tied to the ceiling. We know this force. If I pull it, if I pull the rope will pull me back. This is what the third law says. So when a boy pulls the rope always, we saw it earlier in the last movie, in the last lesson, that the tension will be always away from the boy, away from the body. So the boy pulls the rope downwards. So if I take just at any point in the rope, at this point for example, it will feel tension downwards because the boy pulls it downwards. But the boy feels the tension away from it. This is also the third law. The boy is pulled by the rope and the rope is pulled by the boy. Boy, rope. These are the two masses, two objects which are involved here. The boy pulls the rope pulls the boy. This is the idea of the third law. And again, the simple way to show it, if I push the wall pushes me back. This is the easy way to show it. But you can also see it in more complex ideas. Okay, now that we know the rules, we're going to demonstrate a lot of exercises and problems and solve them by finding their accelerations and tensions and normal forces and G force and every force and whatever. And this is what we are going to do in our next lesson.